So we're going to end up discussing both of these ways that you can talk about the age of a rock. You can do relative age and you can do absolute age. So the relative age is the age of a rock compared to the ages of other rocks around it. You don't give any exact numbers. You just say like this rock is older compared to this other rock or younger. Absolute age is the exact number of years since the rock formed. Now, if at any point this goes too fast, you can always pause the video so that you can get everything written down. So I want to show you an example here. If I am looking at these animals, there's 3 kittens, 1, 2, 3 back here, and there's a dog. So if I were to look at this picture and take a guess and say these kittens are younger than the dog, would that be relative or absolute age? If you said relative age, you are correct. I'm not giving you exact numbers. I'm just telling you this kitten is younger than that dog, or this dog is older than this kitten. Now, if I was giving absolute ages, I would know something about their exact age. Like I could say the dog is 5 years old and the kitten is 3 months old. That's me describing rocks by using their absolute age. I've got a number in there. So the law of superposition, you want to take a moment to write this down. The law of superposition states that the oldest rock layer will always be on the bottom of horizontal sedimentary rock layers if they are undisturbed. So as you write that down, again, feel free to pause the video. But if these were 4 rock layers, assuming they were undisturbed, then number 1 should be the oldest, and number 4 should be the youngest, because the law of superposition says the bottom will be the oldest, the top will be the youngest. If the rock layers are horizontal, which you can see they go across, and they've been left alone. Now here's an actual picture where you can see rock layers, and the oldest is down here and the youngest is up at top. These rock layers are horizontal and they're undisturbed. That's extra information that you don't necessarily know by looking at this. So you don't have to write this down, but when you're determining relative ages of rocks, you also have to consider extrusions, intrusions, faults, folds, and gaps that could occur in the geologic record. So this you can write down. Sometimes you have things called a cross-cutting relationship, where a rock layer or a fault line cuts through another layer. It will always be younger than the layer it cuts through. Okay, so for instance, here in the background, you can see the original rock layers, oldest, then up here's the younger. Now see how this rock layer right here, it cuts through all these rock layers. So that means all these rock layers had to be present, and then something happened that this rock layer formed through them. Anything that you go through, you are younger than it. So this is the youngest rock layer of all of them. Here's another example. You have intrusions. So let's actually watch this form. So when magma melts through existing rock layers and then it cools and hardens and makes other rock without erupting to the surface, the intrusion will be younger than everything around it. So see here, you can see the magma coming up. So see how that came up? It bent up these rock layers. All of these rock layers existed. Originally they were flat and horizontal. Let me go back to the beginning. See how they were all nice and flat? Then this pushed up the rock layers. Now you guys saw it. This orange magma layer is younger than everything that it cut through. We saw all of this existed, and then this happened last. An intrusion, something that intrudes into something, is always younger. So think of an intrusion, an intruder, when someone breaks into a house. You can't break into something that doesn't exist yet. So an intrusion is always younger than what it cuts through. Then you also have extrusions, when magma melts, but it actually erupts onto the surface of the earth. Again, lava will cool, make younger rock than the layers around it. Pause if you need to finish this. Let me show you, if we let this continue, Maybe this goes intrusion. So see, it's inside the earth, intrusion. But what if it actually erupts onto the surface? Here, a volcano is making its way, magma's going up. But now instead of saying inside, it exits. It's now an extrusion. And so this is younger than everything that it cut through. So here's an example of an extrusion. You can see it exited the earth and erupted onto the surface. Here's some examples. A, these are rock layers that are undisturbed. So you can see G is the oldest because it's on the bottom. Then F, E, D, C, B, A is the youngest. Well, sometimes you can have a gap. Maybe erosion came in and worn out the inside. So you can see over here we have all of G, but F, the middle of it got cut out, the middle of E got cut out, and even the middle of A. So sometimes this happens where you're missing some rock layers. Then you can tell that, oh, some erosion happened there. So G, F, E, D, C, B, A is oldest to youngest. If we look at C, see this A, B, C, D? This is before tilting. So the rock layers are nice and flat. D would be the oldest, then C, then B, then A is the youngest. But look, the rock layers got tilted to the side. So when it's tilted to the side, you can still tell D is on the bottom. So D's oldest, C, B, A. And then you can see that tilting happened last. All the rock layers have been affected by the tilting. So the tilting was the last thing to happen. In D, we have an intrusion. So you can see that this layer here is an igneous intrusion. So right, magma cooled and hardened. So that has to make an igneous rock. If I look in the background, oldest to youngest. But see how our intrusion goes through everything? It goes through our oldest layer, even a little bit up into our youngest layer. So the intrusion happened last.